Hello, everyone, to the RSA Space Showcase number 2. This showcase will be focused on space for regeneration, and we will explore how space infrastructure can go beyond helping with sustainability, but actually help creating added value, that being regeneration. So we probably have some fellows in the public, but also people that are not fellows. So as a reminder about the RSA is a society founded 270 years ago. Interestingly enough, one of the co-founders of the RSA was an astronomer that developed telescopes. So besides that, RSA is known having involvement in a wide range of social impact projects, including initiatives to abolish child labor, a scheme to preserve heritage in urban areas, the UK's first tree planting campaign, and of course, the international exhibition at Crystal Palace. It is a huge network of over 31,000 fellows, and it's not only about arts, it's also about manufacturers and commerce. So what is the RSA Space Network about? Is everything RSA plus space, space arts, space manufacturers, space commerce. And this network has three themes: regeneration, prosperity, and health. Earth and society and space are inseparable. We are part of space. We are already in space, as Dr. Teju Somano will say, who's a founding fellow of the Space Group. And being reminded of that is quite important, because if you want to tackle Earth-based challenges, we need to leverage space knowledge, space infrastructure. As an icebreaker, I will have you think about what this number represents. What is the meaning of number 10? If you were in the first showcase, you probably know, you're probably familiar. So please feel free to add in the chat. So number 10 means there are 10 people in space right now. It's a small village, and we're hoping to grow it in the future. We like this number. We hope this number will grow, but it's about big numbers. This is a more relevant number for today's session. So just think about what this number represents for a couple of seconds. If you have some ideas, add in the chat. So it's about regeneration. This number is quite important because it represents the global value of ecosystem services. And if we want this value to grow in the future, if you want to regenerate and add value to the ecosystem services that helps provide us food, water, energy, and prosperity, we need a way to coordinate, to monitor, and to communicate those spatial interventions around the world. So this is exactly what we will explore in this session, how we can leverage space infrastructure and space knowledge to create regeneration on Earth. So I'm happy to announce the first speaker. It's our special guest, Andrew Knight. He's the Global AI, Data and Tech Lead of the Royal Institution of Chartered Surveyors. Andrew, the screen is yours.
Thank you very much. Let me share my screen, and thanks once again for the invitation. So let's see if we can get the technology to work. So let me just share my screen. Right, hopefully everybody can see my screen now. Well, once again, thanks very much for the opportunity to speak here. I will keep this relatively brief as an overview of where I think space can have such a profound effect for the profession I represent. For those of you who aren't aware, who are ICSR, we're a global professional body and standard setter in the built and natural environment, with over 112,000 members qualified worldwide, and we work right across the built and natural environment, and our members work right across the land and property life cycle, across all the different asset types, whether that's land itself, once it's built upon, residential, commercial, alternative and infrastructure assets. And we also have a large role in valuing assets of all time, whether that's land itself, constructed assets, and other asset types as well. My role particularly is to look at the overall effect, both in terms of benefits and some of the challenges of using AI, data, and tech across a sector which historically has not been particularly forward-looking in terms of using data and technology. And it's really appropriate to say that one of our big strategic role at the moment is to look at the whole sustainability issue, not just from the perspective of built assets in terms of their effect on carbon emissions. The built environment is estimated, depending on your calculation, to impact about 39% of all scope 1, 2, and 3 emissions based on the built environment and the use thereof. But our members also have a large role to play in looking at the way land is used, the way land is maintained, how we look at assets from a planning perspective, but also how we look at assets from a climate resilience perspective, and also in terms of land use, looking at crop and the quality of land and issues around water scarceness and all the kind of things that we need to maintain and hopefully build back, including things like biodiversity. So from our point of view, we're obviously based on the ground. Our members are working literally on the ground and upwards in terms of land and building assets. But I think what excites me, having been involved with some of these exhibitors and firms that are working in the space sector, is the potential for us as a profession to get incredibly powerful and valuable data, and for us to be working on that data downstream. And what I wanted to do in a fairly brief presentation was really run through some of the areas where I think already and then potentially in the future we can be very, very grateful beneficiaries of the kind of data we can get from the space sector. We already, to a degree, get some of this data from drones, but obviously getting data from satellites will give us the potential to look at this in a whole new way in terms of scale and reach. So without further ado, a quick sort of canter through some of the areas where I'm already seeing use and potential for this, and maybe some potentials as well. So look at the built environment, clearly a lot of already work going on in terms of high resolution imagery, in terms of monitoring sprawl and zoning and land use changes. Once again, in terms of some of the major infrastructure projects, when those projects, large linear projects, this makes sense in terms of helping us ensure compliance, looking at planning regulations. So a lot of value there in terms of that piece around large linear assets, as well as regional and city level and indeed country level monitoring of what's going on. Clearly, with smart cities, there's a lot of emphasis now in terms of making our cities much more smarter from not just an energy perspective, but managing traffic, managing energy use, and looking at waste disposal. And once again, by combining those IoT devices on the ground with satellite data, that gives us a huge opportunity to manage and view and optimize these things. Clearly, there's now a huge, understandable focus, and I think also driven, post-COVID in terms of well-being and air quality. And we've got to be thinking about not only in the developed world, but particularly in the underdeveloped world, if I can use that phrase. If we think of the situation in India recently in terms of air pollution, there we have significant problems now in terms of air pollution, not only in the developed world, but in other parts of the world where combination of crop burning and other kind of pollutants are causing significant problems. So once again, a real opportunity to monitor and manage at scale the effect of pollutants. And certainly something that's very close to our members is the whole kind of retrofit piece around thermal efficiency of buildings and looking at that at scale. It's one thing to be advising and looking at individual households, for example, about the thermal performance of their houses, but there's a real social impact here about looking at both overheating in terms of heat island effect, in terms of higher temperatures, but also looking from a social value perspective, looking at those areas of cities where we can see deprivation, where we can see poor thermal performance for residential buildings particularly, and where we can target government help and grants and other interventions to really address not only the greenhouse gas issues of poorly performing residential buildings, but also be thinking about the issues surrounding fuel poverty and social deprivation in that way. So once again, we're looking at that increasingly powerful problem of both certain parts of cities being too hot in the summer and clearly too cold in the winter as well. So once again, some great ability to get satellite data help us look at that at scale. If we look at the natural environment, and there's always a danger that our profession is viewed very much through the prism of built assets in terms of buildings of whatever asset type. But I clearly see a huge opportunity here to increase the way we're able to get data on the way we use land. We're particularly concerned about biodiversity and making sure we have a net gain there and development perspective. And I know already of a number of people who are using satellite data to monitor biodiversity. Some nice crossovers there with kind of human crowdsourcing on the surface of the Earth, but also tying that into satellite data. And as you can see, some opportunities there to look at illegal use of land. And I think what is particularly I think important is there are clearly a number of carbon offsetting schemes out there which people are attracted to, but it's incredibly important we get real compliance and real understanding of actually how well those are actually being implemented and whether they really are generating the kind of offsets and the kind of feedback we want in terms of carbon capture. Once again, in terms of agriculture and forestry, a lot of ability here to monitor crop health, soil moisture, pest infestations, with really a drive here to optimize the use of nitrates and other kind of fertilizers and pesticides, and really improve the performance of the agricultural sector in terms of its impact on the environment, because it does have a negative impact. And clearly, there's a huge opportunity here at scale to help us optimize not only food production, but optimize the use of additives in that sense that have that negative effect. Clearly, there's also a lot of activity in rewilding, reforesting, but also that the whole area around fire risk with forest, changes in canopy cover, detecting deforestation to help us encourage and monitor that. So once again, at scale, we have an ability now with satellite data to go beyond the kind of drone data to be counting and once again assessing the success or indeed the damage that certain activities are taking place. So once again, across both built assets and the natural environment, our members are working very closely with a number of these issues. And as ever, we're a sector that historically has been data poor, and the ability of the combination of almost satellite data and then the ability of AI in terms of image recognition, computer vision, will be a very powerful tool for us and is beginning to be a very powerful tool. My last slide is just really around some of the potential things that I think could be helping in the future. I think this whole area of digital twins for cities, I think with satellite data, once again, in collaboration with AI, I think we can have some much smarter ways of planning, managing risk. And once again, for better or for worse, I think we're into a period now where we have to think very carefully about the resilience of our infrastructure and how we work with the forecasting and understanding the assets we already have built to work at how we can make those as resilient as possible. I mentioned earlier about the whole thing around carbon, and there is an opportunity here, I think, to have even more granular monitoring of the carbon footprint of not only residential but industrial and other kind of logistical assets and linear infrastructure assets, to understand how they are actually making sure that they do actually keep their emissions. You can think of examples around already, I think, with methane coming out of the petrochemical sector as well. So once again, a real driver there. And we've all seen, I think, horrible, visuals of the amount of waste and pollution management, particularly in the marine environment, whether it's microplastics and other waste patterns. And once again, an opportunity to use satellite data to manage what is a global problem, but identify particular areas where we can intervene and hopefully roll back this kind of damage. So I remain very optimistic that we have a huge opportunity here as a profession working on the ground to utilize more and more satellite data, work with AI in terms of interpretation, and really have a significant impact on what our members are increasingly trying to do in terms of sustainability, regeneration, which is obviously the topic of today's conversation. So that's my view. Thanks for inviting me along.
Thank you very much, Andrew, for your keynote. The next presentation is from Alan Raw. Alan Raw is co-founder and chief sustainability officer at Pangalactic, a national space tech startup of the year in 2024, supported by the UK Space Agency Accelerator. Also, it's a business-to-business startup of the year for Yorkshire and Northeast in 2024. Alan is also a sustainability ESG practitioner and a director of the Association of Sustainability Practitioners. He's an RSA fellow and co-founder of this RSA Space Network. He's also a member of the Royal Institute of Navigation, Remote Sensing and Photogrammetry Society, and the Association for Geographical Information. He's also a European Commission registered expert in DLT and satellite Earth observation for sustainability. I can go more on and on. He's also a
I
social
think that's
entrepreneur,
probably
science
enough.
writer, and former multi-award winning BBC presenter. So, Alan, the floor is yours.
Yes, that's quite a lot. Thank you very much. I'll share my screen. So you should be able to see that okay now.
All good.
So as Sylvia said, yes, I'm Alan. I'm from Galactic ESG, part of Pangalactic, and I am a proud co-founding fellow of this RSA Space Network. So thank you everybody for coming along and participating in it today. This is fantastic turnout. Today, space technology empowers sustainability, as you've just heard from that amazing presentation from Andrew there. And satellites are our planetary health monitors. They track everything from crop yields to wildlife migration, weather patterns, and as Andrew said, urban development. So recently, satellites revealed to us that we have 3 trillion trees on the planet, which is fantastic, and it's a lot more than was once thought. But they also show us that we're losing irreplaceable natural forests with diverse species, while gaining less biodiverse tree plantations, often very closely planted and not well maintained, and very dark underneath, where not much thrives apart from moss. Satellites are also showing us, though, that forests are growing in places where they were not able to before, but that's because the world is warming. And the other side to that, of course, is once fertile lands are now turning to desert. And as you all know, the protection that trees give us is vital to the health of us and our communities. So our Galactic ESG project puts this technology into action with communities. We're working with partners Optimal Cities, who you're going to hear from a little bit later, and local community organisations. And we're not just planting trees. We're creating lasting green legacies through our projects, including the Memorial Forests Initiative. And each native tree is geolocated, monitored by satellite, and community owned with a maintenance care plan all of its own. But while our trees are benefiting from space technology, we're also trying to help reduce the space industry's own environmental footprint by offering specialized ESG analysis and guidance to space companies, along with opportunities for them to support our galactic forests and create a circular system with us. Now, our analysis and guidance covers the full life cycle of space products, of which there are many. And every component of a spacecraft affects its sustainability footprint. And, of course, all of its supply chain does as well. So if you take the standard aluminium frame that you'd have on a CubeSat, it generates 8.24 kilograms of CO2 per kilo. And then, of course, satellites have solar panels, and they specialized materials requiring careful disposal. And then the circuit boards, which are in this laptop, every spacecraft, all ground stations, and they are complex. They're non-biodegradable components, mixed origins. And so it's really important to understand the impact that all of this crucial elements have, which is quite specialized within ESG assessment for space. But solutions do exist, and there's more appearing all the time, which is fantastic news, because people are inventing things. Lots of green startups. Recycled aerospace aluminium reduces emissions by 95%. Biospace composite, that cuts carbon footprints by 40%. And of course, ESA are doing a lot of research, and their research into wood-based materials revolutionizes critical components and could well be on satellites very soon. Launch systems are also evolving. New methane fuel produces less soot. Hydrogen systems reduce direct emissions, and hybrid technologies promise further improvements. But let's face it, there will always be an impact of everything we do on Earth or off Earth. And the important thing is to acknowledge it, analyse it, reduce it, and continue innovating, while supporting positive impact initiatives, of course, like what cities are doing, and by regenerating biodiverse forests here on Earth. Now, to innovate, we're going to need more experts. and they need to have sustainability values, of course. So it's important to support STEAM education, citizen science programs, and space regeneration forums and meetings like this wonderful RSA Space Network. So thank you very much for joining in, everybody. I hope you're going to be taking part later as well and stay for the whole thing. Through this sharing process, I think that more people can access amazing economic opportunities, and also it's going to empower communities and more green startups. So I'm hoping this has been a good conversation starter. And if anybody wants to get in touch and talk about the finer details of space ESG with me, it's my favourite subject, so feel free to contact me. And I hope that you're going to stay for the conversation and discussion with the Q&A, which Sylvia is going to lead a little later. That's enough from me.
Thank you very much, Alan. Great presentation. Next one is Alina Vizirano. She's a jazz professional and passionate advocate for space exploration and community empowerment. She's a fellow of the RSA, vice chair of the International Astronautical Federation Space Education Outreach Committee, and she's also currently serving as the geospatial manager at Milton Keynes City Council in the UK. Alina, you have the screen and the floor.
Thank you very much. Very nice to meet everyone here. I will go towards why we observe the Earth, especially considering the full understanding of Earth observation and probably all this vibe around. Well, we can do so much with technology. Well, first of all, it's our home. It's important to understand that it's our livelihood. We look into through this technology. We look into the past. We understand very well how particular phenomena have happened. We look into the present and understand as well what's happening now, where it happens, why it happens, but also we can look into forecasting. We can look into addressing the future of resources, understand their finite, they're finite. Also, we look into understand the integrity of our ecosystems. As well, we address survival and we look into how we manage our resources, because important to understand is that why we do so is to gather information about our planet. So, well, we are looking into the Earth observation, especially from the lens of remote sensing. So gather information about Earth using this technology. But we'll do this to understand that this term reflects mostly on how we describe imagery. We are looking into atmosphere, airborne or satellite-borne sensors, and we'll address the observation from as well ground-based sensors. And doing so, remote sensing addresses the spaceborne, so satellites, sensors that are based on satellites, on shuttles, on space station as well, airborne related to manned aircraft, unmanned aerial vehicles, balloons, and the ground-based will be in situ, will be mobile devices, will be devices that we hold. But the benefits of all these technologies is that we look into accurate geolocation. The objective is being always to have consistent measurements of the physical properties of our planet, of our home, of our atmosphere, but also address the repeated coverage of data. And just as example here, considering as we process a satellite image, we take raw information and we pass it through particular lenses of processes. In the end, having an accurate information about a land use case. And further on, we also monitor, I mentioned at the beginning that we monitor the development of our ecosystems or development of particular areas that are usually under development. So here is an example of a use case of Elizabeth Key in Perth in Australia. The space-based imagery, especially in particular, offers this unique source of data about Earth. And here, yeah, we mentioned the accuracy, you mentioned the objective, we mentioned the repeated information. But the fact that we can also look into the past and also see how that evolves and how that the location of the main development of a site is being addressed. So just in this example as a study case, The full Elizabeth K has been set for development, approved 2012, April 2012, and we see how it looked like in February, but also see how the construction has evolved throughout the years and the impact that that construction had on the environment. Particular data sets were captured, were analyzed, were monitored, making sure that everything is under the scope of the project, of the development. And on these type of projects, of course, this being a development site, and also we look into motorways development, nature impact, and so on, it's important to assess this type of time series information to see in the end the end result of that site development. And as a global picture, when we look into assessment of Earth observation satellites and where, in fact, those that are passionate about new technology and how this can be utilized and which fields it covers, well, of course, agriculture is probably one of the most one that we need to assess. We look into the support of local, national, regional activities for agriculture. We look into forestry, fisheries, assessment of impact of famine, so considering the early warning, food security prediction. Further on, assessment of biodiversity, and this is especially when we assess the condition of extent of particular ecosystem, the distribution of species, diversity of particular key populations of those species, climate. Surely climate, and we look outside, it's November, we had already the snow, but how do we model the climate? How we mitigate impact? How we adapt and assess the risk of climate change in the atmosphere, land, towards as well the ocean? Assessment of disasters, it goes without saying, considering the prediction of those, landslides especially, monitor of earthquake and the impact of floods, impact of landslides, of hurricanes or volcanic eruptions, ecosystem as general, and we address the health, the function of change. Considering UK, we have the coastal erosion, nearshore marine systems, and inland water, oceanic islands, and so on this front. Related to energy, we are looking into renewable energy and the energy sources, hydropower, wind power, bioenergy, and the further development of solar and geothermal power. Health, water, weather. This is especially related to monitor those allergens, monitor air quality, and very well health and weather. They're as well impactful. Weather, considering forecasting and warning system using numerical prediction. This is going into especially global and regional data assessment. And on the side of water is understanding the hydrology, the surface water, the groundwater as well, and how we use the water, considering it is a resource that we so need, and the water quality as well. Thank you. And as a final point, I wanted to close out with the national space strategy, the UK goals that have been put forward and presented, being the fact that the UK wants to grow, wants to level up our space economy. We want to promote the values of global Britain, lead on pioneering scientific and inspire the nation through space, protect national interests through space as well, but also use space to deliver on the world and to deliver for the UK citizens and the world on those space on those economic sectors. Thank you.
Thank you very much, Alina, on a very insightful presentation. Now I'm inviting Cesar Rujan. Cesar is CEO of Optimal Cities and a serial entrepreneur with extensive experience in digital innovations and space applications for Earth, space economy, and decision intelligence for development powered by AI and satellites. He's also experienced in working with space agencies and publishing multi-generational plans for sustainable economies on the Moon, Mars, and the upper atmosphere of Venus. Cesar, it's great to have you here.
Thank you, Silvia. You're too kind with that introduction. So essentially, I'd like to share with you a bit of my journey in space, because as Thais Rossomano said, we are already in space. I've been always a space geek. I've always, when I was a kid, I mostly looked outward. I absolutely loved stargazing, and something that I liked more was actually looking for the Mir space station and other satellites. And one of my big issues was in the cities, there was a lot of light pollution, and I had to escape in nature, go to the countryside. And that's how I ended up falling in love with hiking and nature. And as I grew up, I learned that as much as I love technology and digitalization, because I ended up in my career having a foot in digitalization and a foot in space, I realized that to continue digitalization, to continue giving access to education to the rest of the people on Earth, we have to get the materials. And the process of mining and refining a lot of these materials that make the advanced electronics we rely for this conversation today, they have an inverse correlation with the good environment. Add to that, there is a lack of key resources if we consider growth. This is a snapshot from 2014. And I show you a snapshot from 2014 because as I was looking outward, by that time, I wanted to essentially retire on the moon and mine the moon. A company called Planetary Resources was also onto something, and they were looking to mine the asteroids that are have the same orbit with Earth and are essentially even more accessible from a gravity well perspective than the moon. And I ended up helping Planetary Resources in all the ways I could back then, essentially moonlighting for Planetary Resources as I was digitizing the financial sector on Earth. And back in 2014, they were making this satellite. They ended up making two satellites because the first one exploded on an Antares rocket. And they made a satellite that was looking up at the sky in near infrared with the objective of mapping the best orbits, the best satellites, the best asteroids with the best orbits, and the asteroids that most likely have water and platinum. And you can see here an expert from Asteroid Zoo, one of the software systems developed to identify and map these asteroids. And as we were looking outwards, there was the realization that the same system, the same technology, near infrared, can be directed downward. And it can, as many before me today said, it can be used to see how the world ticks. And back in 2014, near infrared was state of the art. But then in 2015, Sentinel-2A multispectral happened. And this really democratized remote sensing, Earth observation, because the data was almost freely available. So I ended up reading this little sentence that the economic cost of soil degradation is estimated by the European Commission in orders of tens of billions of euros. So for a few years, I worked on analyzing desertification in Southern Europe and how satellite imagery and sensor fusion can work together to create methods to prevent that. That's also when I started collaborating with Silvio, and he showed me his vision on how satellites could be applied to improve urban planning. And together we stumbled across the fact that a lot of unfit planning has a lot of financial consequences, multi-trillion-dollar consequences, and it has a huge impact on health. So we set on this journey to improve that and to build the world's smart city planning companion, and take advantage of the even newer satellites with even better optical resolutions and spectral bands to tackle several issues. And the one I think I still have time to talk about is health, is working with the NHS England and figuring out essentially what are good places and bad places for people with pre-existing health conditions in order to improve their health. And that kind of journey that started looking outwards at the stars and at satellites ended up connecting me with amazing people that are as passionate about the space sector as me. And yeah, that's kind of what I wanted to share with you all.
Thank you very much, Cesar. And I think one important takeaway here is space can be such a unifying force, and especially what's really special about the RSA is not only about architects or planners or artists or engineers, is everyone. And this unified network of people coming with different backgrounds, with different stories, can actually create real impact. Now I would like to invite Ishita Ariane. She's also a co-founder of the RSA Space Network. She's a management consultant based in London, working at the crossover of economic advisory, business strategy, innovative finance, partnerships, and policy for enabling climate-positive infrastructure and net zero transition. She has a very impressive background, and I'm looking forward to see her presentation.
Thank you, Silvio. And I think half of my job is done wonderfully by Andrew, Alan, Alina, and Cesar. And so, yeah, I'm feeling very relaxed right now somehow. So, like Silvio mentioned, I am a climate policy and strategy specialist. And you might be wondering, what do I have to do with space? So I help my stakeholders understand the climate risk before we go ahead charting out what do we need to do. And I have recently joined a firm called as ERM into their corporate sustainability and climate solutions. And when I say that we look at climate risk and then start decoding what does this mean for their assets, for their business, and for their supply chain, all of this lens has to be science-based. The targets have to be science-based. And no better place than going back in space to look for those scientific evidence. And like everybody in the webinar today mentioned around how space, from a distance, bring those variables to such proximity. It's just amazing that more than 50% of the essential climate variables that we all rely on to chart out our ways for climate emission reduction or climate adaptation or nature recovery is coming from space. Almost all of the SDGs, 17 of the SDGs, be it in water, be it in food security, be it in infrastructure, sustainable urban development, every single SDG benefits from space. You will see prototype and archetypes of its application in all of it. And I remember Silvio's big number. So, and that's very true. Around $73 billion worth of biodiversity activities, illegal activities, are actually preventable using satellites. Something as simple as illegal logging or deforestation, illegal rigging in illegal deep sea mining, whatever illegal you can think. Theft, robbery, I don't know about them, but rest of this illegal side can be detected from space. So imagine doing policing from space for your climate and for your nature. Similarly, a very amazing factor about the renewable energy sector is that 30% of solar improvements in our solar farms, solar installations is actually coming from forecast from space. Where do you put up your farms? How do you orient it? What sort of solar potential it has? All of it. So this slide basically talks about all of those variables, whether it's your, there's climate change. So yeah, rise in temperature, ocean heat, all of this is interpreted from space. Whether it is about GHG composition in our atmosphere, the CO2, other GHG gases, pretty much interpreted from space. All of your knowledge and your science around oceanography, the chemistry and the physics of ocean, even your marine biology and your marine ecosystem, it is coming from space. The sheer people studying eutrophication in oceans, it's coming from space. Ocean acidification and its multiplied impact on coral reef and dying out of coral reef, that has to do with space. Similarly, the glaciers, the meltdown of Arctic and Antarctic glaciers, or even like glaciers in Himalayas, which is very close to my home where I grew up, is actually in space. And I share a very long relationship with space. And this is back in 2013 when I was a student studying a bachelor's in city planning, when I had a chance to go to ISRO, which is in the apex space institution in India, an equivalent of NASA. So quite a scholarly dream for every Indian student. And I was in ISRO for 2 months, got an internship, and that was my first exposure with space. We were given a task of finding out the deviations on eco-sensitive lands, and this is sub-Himalayan region, like the foothills of Himalayas, quite sensitive ecosystem it has. And we were trying to map out those deviations and violations by ourselves. Yeah, mostly human-led activities, some of them legal, some of them illegal. Constructing road by the government itself is, and if it's hampering with the eco-sensitivity of the region. So that's exactly when I got introduced to remote sensing, earth-based observations, and analytics, and layers of weighted analytics that builds on top of it, and the magic and the solutions it can bring to some complex problems we deal with. So right now I specialize a lot on climate resilience and climate adaptation. So the very equation of climate adaptation rises from it's a factor of risk into vulnerability, the people, into exposure of the hazard. And all three variables are very much related to space, and they benefit a lot from space. Moving forward, as I mentioned, I wanted to zoom down to a specific on, what has space to give to climate adaptation related regeneration. So the regeneration word itself is growing after loss and damage, and that's exactly what climate adaptation is. So makes the job even easier. And there are zillions of application into climate adaptation. It's quite, they're married to each other, but yeah, 6 very clear buckets that I have experienced working in my last 7-8 years is actually here. First is forecasting natural disasters through satellite imagery interpretation, early detection. I am stunned with the kind of space technology emerging for this particular sector specifically, especially the growing rise in wildfire. There's a company which actually does image-based detection, and there's a wildfire in the forest somewhere imagine in the Amazon forest. It has just started and it has only been like 3 to 5 minutes. That can be detected from space in that short span of time, sitting probably somewhere at your space tech agencies. So this is the level of accuracy we have achieved in detecting natural disasters, which is where climate adaptation begins and sits at. Similarly, Google has something called as Fire Satellite. There's a constellation of satellites. They have like a 20-minute duration, and it's a competition going forward. Who can detect it first? Brilliant. Love those competitions in the industry. Similarly, for oceanology, there's a company called as Morris, and there's so many companies on the similar intersection which have built like amazing GIS and remote sensing capabilities for coastal ecosystem reservation, conservation, oil spill detection, and likewise ocean acidification, even measuring sea level rise. Um, Similarly, on land ecosystem monitoring, we have amazing amount of startups coming on radar-based forest monitoring. I am aware of something called as Terra Prima. This company specializes into sustainable mining. So if you live in a country which has a lot of mining activities, do give a check on Terra Prima's solution, because that really it tracks all of the dynamics around mining, and if it is sustainable, happening in a healthy manner or not, related to mining related pollution, mining related illegal lodging and deforestation, um, um, distortion of habitats, wildlife habitats, all of that. Similarly, I think our experts spoke about the adaptive agriculture. Space has a tremendous help in making farming very precise and oriented to the changing climate dynamics of temperature, of erratic rainfall, and there are tremendous amount of startups on that, solutions on that, optimal cities. I remember a conversation with Silvio some time back. They work around it. Similarly, on infrastructure resilience, again, zillions of applications on it. There's a company which really has a very unique solution. So they measure the value of water across your supply chain from space, imagine, and helps reroute your logistics according to the water scarcity. Love the idea. Lastly, the parametric climate related insurances. Yeah, the catastrophic modeling sits on the early detection, sits on the image interpretation from coming from space. So I would say climate adaptation is very much embedded into the space tech. This is more or less like a market landscape, just to show you the length and the breadth of what is happening. And it's not us speaking for the first time, it's the market has caught up. So if you have any ideas on that, better to start working today than to wait. And the market is working across all thematic folds of a very mature market on climate data, which is acquiring the earth observation data from space, emerging and little less mature section on climate solutions, which is mostly transforming those gathered data and now using AI and ML to derive out meaningful information. And all of those startups that we keep talking about, they fit either here or even step forward, which is climate applications, ready to use on boards, on the shelf solutions, and whether it's and that cuts across every fold of life and work we breathe and live in. So whether it's weather and climate risk, or our own insurances, climate insurances, flood insurance, and you'll see your insurer probably tagged in here, or soil carbon, utilities, ESG reporting, carbon offset, emission reporting. Everywhere you have some of the other applications of space. This is the last slide, and this is predominantly what I am currently doing with ERM, and we partner with somebody called as Planet developers. And we have been, I'm quite new to it, but I've been learning from my team members around in here. We use space a lot, even if we say that we are a corporate sustainability and climate solutions team. And it's embedded in our GHG emissions inventory. We take help of gathering those emission data from the space, quantification from the space, whether when it comes to nature-based solutions design, nature accounting, very helpful to monitor and even plan for look out for carbon offsets and removal via space. It gives you a good idea around the volume of biomass present, the health of biomass present, all from a very distance. Similarly, nature and biodiversity assessment, as we spoke, capital projects, big infrastructure projects are benefiting from space tech as well. Similarly, tracking any illegal construction, something which goes back to my experience from ISRO, is again coming from this space. So I think there are many to many linkages of space tech to climate, whether it's mitigation, adaptation, or nature recovery. And I'm sure we all can look out for those tangents and pull those levers and exploit space for the benefit of things which are around us.
Thank you very much, Ishta. Very extensive and very insightful presentation. I would like to address some of the questions to the panel, starting with Andrew Knight and Alina Vizirano. So it's obviously the issue is there, the need for regeneration, and also the technologies are here as well. But in your experience, Andrew and Alina, what are the biggest bottlenecks in adopting those technologies or using even data from satellites?
I suppose if I take that first, it's probably still awareness raising and education that this data is available and knowing where to find it. I think it's very easy for us who are very attuned to the possibilities and what's already being done. I think for a lot of people that this is still a bit of a mystery, and they probably don't know where to start and where they could access this data from. And I think probably a sense that it might be too expensive, that then the cost might be prohibitive.
Absolutely, I echo your answer, Andrew. Indeed, seeing in the council. So when I joined almost 2 years ago, I really wanted to bring the innovation in. So partner with Geospatial Commission, looked into Airbus datasets, Pleiades, but that's because I know what that data stands for and what it is. But this also prompted me to realize that, well, we needed to upskill, we needed to address how we use this data, create use case scenarios, and understand where it can be suitable to fit in space, especially planning, looking into that example from Australia. So it was something that I wanted to study and understand how others have used it at local government and how we can use it and implement it as well here. And of course, various companies in the UK are using it, but these are for government projects mainly. So we look into HS2 and so on, monitoring those impact assessments. And as Ishita mentioned, so many use case examples, but we need more awareness and education. So skills development is of massive need.
Thank you very much, both. And when it's about communicating things, looking forward in the next 5 to 10 years, what you think will be, and this is a question mainly targeted to Alan Raw. Alan, what do you think are the main ways to communicate this to the public? How to make the public aware of those issues and how they can even leverage that information and how they can engage with other stakeholders?
Well, there is definitely a misconception that space data is inaccessible, and that's understandable. People would just think, well, it's so far away. But that's despite massive efforts by ESA to make it accessible, with Copernicus data being free, and training courses that they've put out for free as well to access that. I think there needs to be more general community engagements done by people who are acting in the space. And that means working with communities to show them the real benefits. But to do that, you've got to go to the communities and see what benefits they actually need. So what are the needs? And if you can identify the needs, there's a good chance that space technology can actually address some of those needs. So if you're working with communities to celebrate the small things that they're already doing themselves with community gardens and planting schemes, and then you can show them that they are able to actually monitor that progress, the health of the vegetation, the moisture, the flooding that they may be mitigating themselves, then through that kind of STEAM education, that is true engagement. And then from there, people can access the free courses. They can get together and maybe have a small startup of their own. And who knows where that could go.
Thank you very much, Alan. The next question is focused on Caesar and Ishita. So, from your experience, what do you think are the geographies or the issues that need to be addressed first to have a regeneration, a proper regeneration for the next 15 to 20 years?
Would you like to go first, Ishita, or should I?
Please go ahead.
Okay, so I think mitigation should be something that's very important. We have changes that are happening in areas where we already have infrastructure, and I think we should prioritize the areas where there's already infrastructure, the low-hanging fruits, and stop this kind of negative change, like desertification in Southern Europe is one of them. Because the process of doing this with a supply chain accessible is going to create a lot of learning points and is going to enable us to actually do it in places where there's no infrastructure, and it help us find ways to create new methods and tools for those places. For instance, I think Alan mentioned that the tundra is or Flo mentioned that the tundra could be forested. So we could have planes that drop seed pods, and do this in a planned way without having monocultures. And yeah, but first we should take the low-hanging fruit where we already have infrastructure.
Yeah. And just to add it here, I feel, Silvio, we have the solutions and applications that we are looking for. They're coming up in a very natural manner, and there's some impetus, especially on the climate adaptation, which is relatively a newer side, a less mature side for space tech applications. It's now a matter of taking these applications and solutions to the people who need it, and that's exactly the human touch or the human story missing from the space tech and climate adaptation right now. So yeah, looking at the vulnerable 20 countries. I know we are too focused on G7, G14 sort of buckets, but vulnerable 20 countries, as IMF categorizes it, could be the best places where these solutions should be deployed and scaled up. Emerging countries which are struck at the climate hotspots of natural disasters could be good places to deploy it. The COP29 just winded up, and we were talking about loss and damage fund, and nobody has been able to figure out what should be the equation for this loss and damage fund in terms of estimating how it should be contributed or disseminating and applying it on real scenarios. And I think it should be space-based, I mean, space tech-based and science-based. It cannot be just any erratic equation there.
Thank you very much, Ishta. A last question before wrapping up. How can more global frameworks for Earth observation data standardization and coordination between many data providers can streamline coverage, supporting better regeneration efforts? And I think this is something that we discussed quite a lot, Andrew, but I think it would be good to have your thoughts as well as the other panelists.
Yeah, I think, the whole standards debate does, cause a lot of issues across the built and natural environment. And we have so many technologies, we have so many proprietary pieces of innovation. I've changed my thinking to some extent, in the sense that I think we have to live in a world where we will be presented with lots of different data sets in different formats that won't necessarily coalesce around, fewer standards. The challenge is always that innovation seems to drive yet another standard. However, I remain optimistic that if we leverage AI, we can probably deal with a multiplicity of data sources and data formats and use the AI to do that work for us and make sure we can get data that's accessible and usable, almost irrespective of where it comes from. I know that sounds a little utopian, but I take the view that I think we're probably better off looking at not trying to impose standards which may be just impractical, but to use the technology that's evolving to help us consume data and represent that in whatever format we need.
Thank you very much. Any other thoughts on this?
Yes, on one aspect that I have addressed, especially at the last International Astronautical Congress, just October, closing up the final event. We looked at collaboration, and one of the panels that I led was related to geospatial technologies for natural disasters and sustainable development, urban planning and sustainable development. But we noticed that the collaboration is something that is of massive need, because as in global collaboration on standards, we have had access to data sets coming from Asia, from partners from Korea, South Korea, as well data coming from NASA, from Landsat sensors. Well, we need to understand what these data stand for, exactly the understanding on the side of standardization, and access to this metadata, access to information in the background of how we can access this, how we manipulate the data, how we use it on our infrastructure is not easily available. And there is a need for multilateral initiatives related to communication, collaboration. All the side of Earth observation infrastructure needs to be better addressed. What we applaud is the open access. So this is a massive, well done on NASA, especially on ESA, on Copernicus. Open access is available, is easily accessible. So all this information is there. But transparency related to further data sets coming from more private companies is not, as at least to have access. And I know personally about the Living Atlas from Airbus, which is of great use. We have access through the authority, through the council authority. We have access data from this. But that's thankfully because UK and Ordnance Survey have access also already to Pleiades and Airbus datasets. It doesn't happen on other countries, or I don't know, of course, of other countries' framework developments. But there is a need on further access to these datasets or publication of them and what's available and how can we access them.
Thank you very much, Elena. Alan, I think you have a point here to address. Yeah.
Just if we've got time, I just wanted to mention it. I mean, one of the earlier questions, it could have been Trevor, I'm not sure who posted it, but it was about the Lisbon Declaration. And if you look at the Lisbon Declaration, it talks about acknowledging the Earth observation tools and the space tools for sustainability. But the main 4 points that declaration, I remember, came up with was transparency, trust, youth participation and alignment, which is pretty much what we've been talking about. And if we just implement that, that would solve a lot of these problems that we've just been discussing, especially that last question.
Thank you very much, everyone. This is the finish line, the end of this showcase, but this is the beginning of a long series of other events, part of the RSA Space Network. So I also included in the chat, if you're a fellow and you want to join the discussion, you can join via Circle in the Space Network. If you're not a fellow, consider becoming one. Scan the QR code. And a small teaser for the ones that are still in the call. We have an upcoming space showcase, a very exciting set of panelists focused on space for health from all over the world. We have from Norway, from US, from UK, and beyond. So if you want to join the next one, scan the QR code or join RSA or RSA Space Circle so you make sure you're up to date with the latest events. Thank you very much for joining, and I'm looking forward to the next showcase. Thank you.